Okay, now we'll go ahead and get started. So welcome to our talk. This is the introduction to the OWASP API security project, which is a project that Leif and I have been working on for probably about the last 8 months or so. We're really happy to finally be unveiling that, and hopefully getting some of you people involved should be pretty good. This talk is a little bit different than some of the other talks at this conference and some of the other talks that Leif and I have given in the past. We'll display some of the research that we've done, but really what we did as our research for this project is what we consider somewhat preliminary. We basically took the data that we could find and the statistics that we could find and compiled that into what we think is a pretty good first step for this project. But really, more than anything else, this is a call for participation. We're not saying that this is done and perfect, but we'd like to get the project some exposure and hopefully pique some of your guys' interest. So the agenda for today is pretty straightforward. I'm going to do the general introduction stuff. You know, who are we? What's OWASP? You know, why are we even doing this project in the first place? We'll give some real-world examples, both that we've seen in the media and that Leif has seen through working for BugCrowd, which gives him some nice visibility there. We'll go through the top 10 API security risks, or at least what we have of those so far. And then we'll talk about sort of how you can help, how you can join the project, how you can be involved in one way or another. So to start off, for those of you that don't know me, and I don't think I know too many people here, my name is David Shaw. I'm on Twitter at dshaw_. The other guy is not me. I'm the Chief Information Security Officer at a software company called Appfolio, based in Santa Barbara, California. It was a pretty rough travel to get here. We got here like early this morning after several canceled flights. I was the former CTO at Redspin, which is an application security consultancy, until it was acquired last year. I've presented at NolaCon twice before on more in-depth technical security research. Again, that's not really the point of this talk today. And I will drink with you either with our selection of booze here, or hopefully the bar's open, at which point we can just go do that. I'm happy to talk about these ideas or just security in general with anyone at any time, or not with a drink. If you don't drink, that's fine. But I'll be here throughout the weekend, so hopefully you can meet some of you guys and have some good conversations.
I'm Leif Dreizler. I have a much more unique Twitter handle, considering that there's only one Leif Dreizler. I'm a security engineer for BugCrowd, and I used to work with David at Redspin. I've given conference presentations at a couple different B-sides and things like that, and I'm the Indiana Jones of memes, so hopefully you find some enjoyment from those.
Yeah, as a side note, I mentioned our flight was canceled, so I got in this morning really tired, about 90 minutes of sleep. And I find Leif, and I'm like, all right, are we good to give this talk? And he's like, yeah, I made a lot of cool additions for you. And I'm like, what? Like, what do you mean, man? Like, I thought we finalized it. Like, we had the slide deck. Everything was good. He's like, well, I thought it'd be a good idea to just add in some memes and images. I'm like, all right. So we spent
meme archaeologist. I wasn't gonna have it be devoid.
We spent probably 45 minutes going through and removing memes from the talk after. It's not a joke. So how many of you, just so I can get sort of like a quick survey, how many people are familiar with OWASP? Okay, cool. So that's most people, probably like half, 2/3. That's good. OWASP. So OWASP, for those that don't know, is the Open Web Application Security Project, which is just a nice acronym. It sounds cool. Basically, that's a huge repository of information on the OWASP.org wiki. If you've never been there and you work in security, I strongly recommend it. A lot of cheat sheets, documentation, things like that. They've released some tools that aren't bad. ZAP, the Z attack proxy, is basically a free and open source intercepting proxy. They have some tools that are bad, but we won't talk about that. Probably not good for the talk. And they also organize some pretty high-profile conferences. The most high-profile of those probably being AppSec USA every year. Also, they have AppSec EU. Leif and I are staff at AppSec California. So, you know, they're a pretty reputable organization. They really try to give back to the community, which is why we're trying to participate with them to sort of, you know, move things forward. So in addition to their tools and their projects and the conferences, OWASP also has documentation projects, and some of these are actually pretty famous, right? So the top 10 guides are pretty much, if you're like, hey, like what are some web security vulnerabilities, it's going to come up. A bunch of pen testing firms use like the OWASP web application top 10 as like security categories or finding categories. It's very common. You can't really avoid it. But they also have, like the mobile security top 10, the Internet of Things top 10 security risks. That's sort of like their flagship documents that people use. It gets OWASP exposure, and they're big fans of that. So the OWASP API Security Project sort of is seeking to document the pitfalls and mitigations of those pitfalls in deploying APIs and also assessing those APIs. If you try to say, hey, I'm a pen tester, I'm trying to assess API security, you'll probably notice there isn't really that much documentation, probably because in general it's harder than assessing a web application. So we're trying to also seek to address sort of that shortage there. But after I just told you all of this documentation that's on the OWASP wiki and how great it is and woohoo, like go OWASP, you might be wondering, okay, well, why do you actually even need to create this document, this project? Well, API security is really important. It's growing in importance pretty much every month. The rate at which companies are deploying APIs is increasing very rapidly. And there's sort of a couple reasons for that, right? So public APIs, meaning a user or a client can connect and do things via a public API. Very widespread, but also internal APIs and microservices are continuing to sort of grow in adoption all the time. So at the company where I work, we sort of have one monolithic Rails app. That's the primary flagship product. But when we add on to that, or if we add tertiary services to that, those are deployed as microservices, and we just write APIs. We can have both the application or other applications query each other and basically make things work fast in an easily deployed way. It's very useful. You also have sort of the challenge of platform-based issues, right? So if you're, hey, I'm hot new startup, Bug Cloud, and you decide that you want to just have your application work on the Facebook platform, well, you're basically only interacting via APIs, right? I mean, without the APIs of Facebook, without the platform on which you're basing your application, nothing would work.
So just a couple examples that have come out recently. The first one is recently Microsoft put out a blog post stating that they're working on a REST API that would allow you to configure and manage IIS. The goal of this is to make IIS configurable from any device that knows how to make a web call, specifically mobile applications. So, configuring something as important as your web server from an API, there's a lot of security concerns that would be in place with having something like that be more open. Another example is in March of this year, Uber released a blog post detailing the specifics of their bug bounty program, including documentation of APIs. These APIs can do things like find nearby drivers, split fares with friends, or allow people to build applications that interact with Uber. So there's a lot of functionality that APIs contain, and some of it can be very sensitive. Imagine if you could, share a ride to the airport or back from the airport to NolaCon, and I could make it so that I'm paying significantly less fare than David.
Thanks.
Not that I would do that.
I believe you.
I would expense it.
I'm gonna make this bigger.
Yeah.
I guess I'm not gonna make it bigger. Okay. So web applications, as I'm sure most people here know, if they're in sort of the security community, have pretty major security problems, right? I mean, we hear about, major breaches through web applications pretty much all the time. SQL injection, cross-site scripting, cross-site request forgery, et cetera, right? But with the exception of, sort of like weird side channel attacks, there's not really that many new techniques for breaking these web applications, right? I mean, yeah, there might be particularly cool instances of, hey, we found this really cool SQL injection or XXE or whatever, or even, hey, we found this minor cross-site scripting bug and we were able to hook in beef and, take over an organization. That's great. But, in general, these vulnerability types are solved. And I put the asterisk here because obviously people are still getting breached that way. But the actual vulnerability type, we know how to tell a developer not to write SQL injection in their code, not to write cross-site scripting in their code. It's a solved vulnerability type. yeah, I mean, you can just mitigate these things, right? So that said, many APIs, especially ones that are being sort of written as maybe an afterthought of more flagship products from major organizations, are sort of like, okay, well, a different team is going to write this, and it's going to be done much later, and they're not going to have necessarily the same protection. So, for example, Instagram right now is a fully functional, basically, we won't say it's completely secure, but fine, fairly hardened application. That basically, if you add in an external API to post photos or to do all these different tasks, you can basically add in security holes. If you're not doing the exact same permissions check that you might be doing via the actual application, then you're going to introduce holes where what you think you're doing is just making something easier to use or opening up your platform for further use. So a good example of this is that last year, United Airlines launched a bug bounty program. Maybe the successful thing that they fly now. So I'm a little bitter from yesterday. So basically, one of the most critical vulnerabilities that was released through this is basically by using the mobile app, you can see API requests because they spun up an API to support the mobile app. Now that's invisible to the user. So users aren't actually saying, oh, I have an API key, I'm going to go through, I'm going to do all this stuff. It's really just, oh, well, if I open up, an intercepting proxy or I take a packet capture or whatever, you can see the actual API requests on the wire. So basically what happened in this particular instance, and I'm not going to go through the full case study, but basically in this particular instance, if you had someone's mileage plus number, which you could, it's not really considered super sensitive, you put it in hotel bookings, things like that, you get what's called a record locator. And using this record locator, you can make a series of requests that would basically unveil flight plans, allow you to change flight plans, would reveal last four of credit card, would basically do all these things that not only does it, it's an awesome. No, man. No, please don't be. It's fine. But basically, you could go through, and with this record locator, you could change flights. You could add yourself to flights. You could change names. You could take someone's, well, at least the last four of their credit card number. And it's really bad, right? That was super critical. So major organizations are basically accidentally exposing sensitive data and methods via API access. Clearly they're not meaning to do it, but they're saying, oh, everyone's releasing these APIs, we should do that too. Or even we have a legitimate use case to do so, but we're not putting the same security controls or even thought into the dev process that would be done for the actual formal applications. Okay. So, oh yeah, roughly a quarter of the bounties that people have seen on BugCrowd and HackerOne sort of include the API in their scope, and that's only things I believe that were specifically called out. So like the United Airlines thing isn't saying, hey, we have a specific API that we'd like you to test, but they had a mobile app that was in scope, which made API calls on the back end. Also, we're working off of very tiny thumbnails of slides, in case you're wondering. Yeah, yeah, this is awful. Yeah, we're working on it. Okay, all right. Leif did something. That was probably a poor choice.
There we go.
Is it up? Is that displaying slides?
Yeah. It should be right.
I'm asking you. I'm asking you.
No, it's mirrored. We're good. All right. So I'm technical. So we're going to go over some API security examples. One of the recent Magento security bulletins, they do fairly detailed patch notes. For those of you who aren't familiar with Magento, they help companies run e-commerce platforms. A ton of companies use them. They're part of the eBay family of companies. In their most recent security bulletin, 50%, so 3 of 6 of the vulnerabilities that were fixed were API-related vulnerabilities. There was one critical that was remote code execution. There was one high, which had to do with account hijacking, and there was a medium, which had to do with being able to manipulate items in a guest cart. So if you have you haven't logged in yet, you're working on a cart, somebody else could make manipulations to your cart. Another couple examples that were in the news recently, there was one from Qualcomm that was, now that I don't have the notes up, it's gingerbread through lollipop, I think. So not the most recent version of Android, But just to give you guys an idea, the versions that are affected cover about 92% of Android devices. Obviously, not all of those have Qualcomm chipsets, so not 90% of Android devices were vulnerable, but still a huge percentage. And the vulnerability, I forget what the API name was, but it was pretty low level. Obviously, if it's a vulnerability in Qualcomm, they make the radio chipsets for a lot of cell phones. It allows you to read text messages, view the call logs, and also perform radio actions from the device. So radio actions are basically all of the stuff that you barely use your phone for anymore. So not the apps, not browsing the web, but some of the more basic things like sending text messages and calling people. Another one was the Instagram bug that caught a lot of news outlets due to the age of the reporter. A 10-year-old kid found a bug in Instagram that allowed you to delete comments from other users and got rewarded $10,000. So that was in an internal API within the Instagram code that had that vulnerability. Another couple ones that are interesting and fun to look up after this. The first one was a manipulation of a Tesla API. So whether or not you release the API to people, if it's in something that they can access, they're going to poke around. They're going to either look at your source code if they can. If not, they're going to look at the requests on the wire. So both of these stories come from people basically looking at the web calls from the mobile clients that Snapchat and Tesla have. And I don't know if you guys saw the video, but somebody used Alexa from Amazon Echo to be able to open up their garage door, turn on the Tesla, and pull their car out of the garage, similar to Knight Rider. So that one was kind of fun. The Snapchat one. Speaking of AppSec California, if you ever want to come out to California during January, we basically don't have winter if you've never been out there. So if you're from an area that has winter, it can be pretty fun to come out. Anyway, the director of InfoSec at Snapchat this year gave, I thought it was a really good presentation about all the issues that they have with people manipulating the APIs and using them for functionality that they weren't designed for. So Snapchat doesn't release a public API for their program, but what people will do is they'll piece together different versions of API calls, maybe from an older version in Android, a newer version of iOS, something else in the middle. I don't know if there's a version for Windows Phone, but you might pull something from there too. And basically what people will do is they'll come up with these third-party additions to Snapchat that will allow for new functionality. So maybe you can save messages without notifying the person that sent it to you or things like that. And this is a major problem for them because they can't just shut down these older versions of the APIs because they risk locking out people that are using older versions of Snapchat. Obviously, you know, the more users that they have, the more money that they're making. So it's very difficult for them to monitor the functionality of these older APIs and things that shouldn't be happening and allowing people's accounts to get compromised. I don't know if you guys remember, but in 2014, there was a major hack against Snapchat. Snapchat said that it was actually third-party services that people had been logging into with their Snapchat credentials. The way that those third-party services work are based off of manipulating the API and using it for things that it wasn't intended for. So David mentioned this a little bit earlier, but APIs are often neglected during testing. Usually APIs are harder and less fun to test. I know that when I was doing pen testing, I mean, what would you rather look at? Some web app that you don't know what the heck it's doing, but you can still find fun things to break in it? Or just a bunch of sample API calls where you have to do a bunch of work to fill in parameters. You know, you're not getting the same error messaging that you're frequently getting from the web application. Just generally not as fun, in my opinion, to mess around with just the text. It's more fun to break stuff that you can see. In addition, depending on how robust the API is, maybe it's more of like an SDK, you might actually have to build something, which not all web pen testers are comfortable doing, especially you know, if you don't really have as strong of a development background. And even if you do, it's still just way more time consuming than just clicking through somebody's web application, Burp's doing some stuff in the background, you're looking for some stuff on your own. With the APIs, you're going to have to copy and paste a bunch of stuff into whatever intercepting proxy you're using. So some of the standard tools that people rely on aren't built with APIs in mind for testing. we didn't really know where to fit this meme, but I just typed in Spider-Man security meme, and this came up, so I felt like it needed to be somewhere. So we just put it to signify that David was going to take back over for a couple of slides.
Yeah. Thanks, Leif. Yeah, I couldn't remove that meme, and I mean, look at that. It's amazing.
So
All right,
good.
it's so good.
Security
It's
API
just
is
too
still
relevant. It's
working.
just too relevant. I don't even understand. I feel like it's probably sarcastic. Okay, so as part of this project, and like I said, we're trying to do this, documentation portal. We're trying to actually create things that will help developers and will help pen testers. Although if they don't know how to code, that's going to be difficult no matter what. But basically, as sort of like a document that we can release to the world that'll actually bring some exposure to the project and will actually, actually help out some people quickly. We decided to put together an API security top 10. As I mentioned before, OWASP's really all about these top 10 lists. I don't know why. I feel like it could be a BuzzFeed article, but we decided to, sort of just go with the schema and say,
As
all
long
right,
as it's not separate pages for each one, I think
we're going to write an API security listicle next. This is a release candidate. As I mentioned at the beginning of the talk, we looked at the statistics that Leif could put together from BugCrowd. We looked at major high-profile breaches that we could see in the media, and we said, okay, I think we can correlate these into what we find to be major pitfalls. You guys might have a different experience. We're more than happy, in fact, very much encourage people to give us feedback. If you say, hey, like, you're missing something, or hey, this isn't accurate, we'd love to hear that. It'd be a little sad, but we'd love to hear that. Okay, so like I said, this is based on sort of the aggregate data. We couldn't release the full data that we use from BugCrowd because that's actually people's security findings. We don't know if they fixed them all, things along those lines. But we're going to actually release the top 10 right after this talk. You guys will be able to download it, assuming I can find my laptop and Wi-Fi and stuff like that. We'll probably hit the bar first. Okay.
All right. No meme shift.
Yeah, we should
So
have done that.
just every time.
Poor decision.
Just saying meme. So everybody who's familiar with the OWASP top 10 is familiar with things like cross-site scripting, SQL injection, command injection. We decided to kind of just bundle all of these into a single category. Injection has been the top #1 slot of the OWASP top 10. We thought, it's getting a little bit too much traction on its own. Bring it down a couple notches and combine it with some of the other groups. And from an API perspective, a lot of these kind of fall under the same category of remediation or prevention. It all boils down to improper data sanitization. Tables and shit, bro. So the second one is insufficient access control. This occurs when API methods are not checked correctly for privileges. So in this example, there's a device manufacturer, and all it was checking was making sure that you were a user in the organization that was able to make configuration changes. So if I'm a user and David is a super admin, it didn't do any checking to make sure that I wasn't a super admin. I could do any of the changes that he did just by having a valid set of credentials. It basically made the role-based access control for the device meaningless, considering you could have the lowest tier performing the highest actions. Another example of this is the Instagram hack. It wasn't checking to make sure that the person deleting the comment was the person that had actually posted it. So if I posted a comment on some of David's Instagram photos that he didn't like, he would be able to, delete them from his account. You might actually be able to do that anyway. I guess I could delete things that he had posted on his own photos. That's a better example, and one that actually makes sense. The next category is insecure direct object reference. This is probably one of my favorite ones from doing web pen testing from the normal OWASP top 10. I will say that my favorite is actually CSurf, just because it seems so sneaky and it combines things with social engineering. I don't know why. I always just like CSurf findings, but IDOR, or insecure direct object reference, is definitely an old favorite from the web app top 10. This example was another device manufacturer, and what would happen during the registration process is, as part of a post request, you would send along the device's serial number. As part of that registration, it would lock the device to my account so that nobody else could register it. Generally a good idea. The problem is you could just iterate through and register as many devices to your account as possible, which would then lock out all of the other people that had actually bought that device. So if we both bought the same little device, I could just register David's and then he couldn't use it. Okay, yeah. So this one is similar, or another one for insecure direct object reference. This comes from a company that companies will use to send out questions to people. You've probably gotten one that's like, oh, hey, how happy were you with this product? Please rate it 1 to 5. You know, maybe there's a section for comments or something like that. As part of this, you could initiate a request that would allow you to gain access to anyone's responses. So whether or not they were in your organization, whether or not it was a survey that you had even sent out to your customers, you were able to access that information. So you could get information about how happy somebody was with your competitors, assuming that they're using the same service, and that you could iterate through and actually find their company. This next one, I believe, was part of the OWASP Top 10 in 2010. And then there's a similar category in the OWASP Mobile Application Top 10, except they call it Insecure Cryptography, I think, and IoT. I think that also covers stuff that's on the devices too, so it's a little bit more broad. But without web browsers spewing big errors, which they've gotten pretty good at, especially Chrome. Chrome has been pretty aggressive with deprecating things like SHA-1, self-signed certificates, things like that. I mean, there's a ton of reasons now why companies at least have the little red marks through the HTTPS, if not a big old warning that you know, freaks people out. We see frequently with APIs that people just aren't even adding the S in HTTPS. I mean, it's really that easy for a lot of these things. For whatever reason, maybe there was some problem that you had earlier, maybe there was like some certificate problems, and whatever library you were using for that was failing and not letting you wise. So as a developer, you're like, all right, well, let's just do HTTP and it works, so you just don't revisit it.
We see that a lot with wrappers too. So if like a public API is released, oftentimes oftentimes, like for example, someone will write like a gem to make it easily accessible, or like some other sort of package. And oftentimes, even though the actual API documentation is saying, hey, you know, this is an HTTPS call, do this, those same people that are releasing that API will not restrict non-HTTPS requests. And then you have the third party making this wrapper, don't do it, that
I was watching Wild Wild West earlier, Jim West.
That would actually make your implementation insecure, even though the API itself is documenting itself correctly. They've left a hole open.
An example of this was there was the VTech breach at the end of last year. For those unfamiliar, it was a toy manufacturer, and as part of the breach, there was 5 million parents' names, addresses, other PII, as well as the names and birthdays of 200,000 children. So that definitely got a lot of press. It was unclear exactly where that breach came from. It seemed to be SQL injection, not related to transport layer security. The reason why I brought it up is because Troy Hunt did a little bit of extra digging into the security of their products and their websites, and found that pretty much nothing was using HTTPS for the web calls. So this is definitely something that's still a major problem. Even if it wasn't how that company got breached, it was a pretty big breach of last year. So we thought that it was worth mentioning as an example. Sensitive data exposure. This occurs when APIs allow queries that are excessively broad. A major example of this would be social graph style APIs that seem to be particularly vulnerable. An example of this would be the Grindr vulnerability from a couple of years ago. Basically, as an unauthenticated user, you could log into Grindr and say, show me the 50 closest people that are also signed up for Grindr. If those users had their location shared within the application, you could use a process called trilateration, which is basically you make that same request 3 times, and based off of your location changing and the new distance for those people, I guess you have to move around between the requests. But so you could move around a little bit, make the same request, and as long as that person was present for all of those requests and they didn't move, you could use that to get their exact location using some of the math and geometry that's on the screen. It would expose somebody's exact location. So so this was a problem in countries that have rather strict anti-gay laws. You could use it to find not just kind of the general location of where somebody's at, but you could use it to pinpoint exactly.
Or just stalk people.
Yeah,
I mean,
stalking too.
Yeah.
Yeah.
Exactly.
That's how he found me to work at Redspin.
Exactly, yeah. Is it? Is it?
I think it was a referral.
Yeah.
All right.
As a side note, we also had a pretty long conversation about trilateration versus triangulation. Different things. Okay, so weak server-side security, pretty straightforward in terms of what that actually means. It's similar to known issues or known vulnerabilities in third-party components. It basically occurs when the server itself or the API endpoint is vulnerable. So there's a lot of different ways that this can come to light and a lot of different ways that we've seen this happening in the real world. For example, if you're opening ACLs on API endpoints, you might just say, yeah, whatever, just all traffic can go to this. We're just going to remove all security. And then your attack surface will obviously increase. If you're allowing every service to be hit, you'll have the standard internet noise that everything open to the internet will see. Then there's also server-side vulnerabilities like Heartbleed, Shellshock, Image Tragic. I chose the cool named ones because security. But seriously, I mean, we see things like, oh, we have this API endpoint. It's been running for 5 years. Basically, sometimes people don't monitor it. Oftentimes you see like ops teams that aren't really touching what they consider to be developer-controlled API endpoints. And then when something like Heartbleed comes out, or Image Tragic, if it's an image processing API, people don't necessarily patch it. And then you have vulnerable systems just sitting on the internet. Improper key handling is kind of cool because it's unique to APIs. This is I gave Leif credit for this image. This is pretty great. Improper key handling. Basically, it's API specific in that generally web applications aren't manually giving you keys to use, right? I mean, you could say, all right, well, there's cert pinning, sort of, HSTS, things like that, but really it's sort of API specific. API keys, for those of you who may not have implemented an API, basically popular authentication mechanisms, but aren't always managed in a sane way. So like, if you're going to maybe say like have an HMAC for every request that you're making, okay, that's pretty secure. You're actually making sure that they have the key, they have a secret, everything's working. But a lot of times we see, okay, here's a 40 character alphanumeric string. This is your key. Don't lose it. This is all you need, right? The problem is it's not always, say, a 40 character random string. We see things like lack of key verification, meaning if you have the right schema and that it's, say, 40 characters, doesn't have special characters, they say, oh, this looks like a valid key. We're going to actually allow any requests from that, which is pretty bad. Sequential or otherwise predictable keys, spoofable admin bits and keys, like having a secondary key where you're basically like, and I'm an admin. Keys and URLs, etc. So we have basically a really simple example for this. This actually highlights two of those problems. If you're sending a GET request to an API, in this case, you're listing users, and you have an API key, first of all, this would definitely be in the URL in the GET request, right, because it's a GET. And also, if your key is something like 1336, that's probably going to be sequential, right? A, it's only 4 digits, and B, I mean, it's a pretty low one at that. So a lot of organizations will say, yeah, just increment that counter. They use the ID of, the database row, and that's how it works. So clearly, if you have that, you can very easily sort of brute force everyone else's, just quickly run through 10,000 numbers, and all of a sudden you have access to everyone's account. Inconsistent API functionality is something that we alluded to a little bit before, and is generally pretty severe. This basically occurs when API functions work fundamentally differently than those in the primary application. So a secondary team came in, wrote the API to basically say, hey, we're going to mimic all the functions. But again, they're not spending maybe an 18-month dev cycle on creating like a really nice hardened application. They don't have the security team coming in and doing code review. There's like, yeah, we can just open up these functions. It's fine. We'll just write to the database. An example here would be, in like a Facebook web app, tagging should share the photo with the person who's tagged. But sometimes, like if you're tagged via API access, photos just shared with everyone, right? I mean, that's just not correctly mimicking the actual function that you're trying to implement via the API. Just saying, yeah, this is pretty much doing what it's supposed to. One of the really high-profile examples of this would be sort of rate limiting in the user interface versus the API. The most well-known probably being the Apple celebrity photo leak. Basically, if you're logging into an iCloud account, you can do something like, I don't know, 5 attempts and then it slows you down or locks you out, something like that. Pretty standard to have in most applications. But there was an API endpoint where you could basically just brute force that. It didn't have that same rate limiting in place for that particular API request. So then you can say, okay, I know whose email address I'm trying to get into. I can go through, 10 million passwords, and yeah, it'll take some time to send those requests, but there's no actual rate limiting. You can actually brute force someone's password that way. It's unclear, I guess, as a side note, if that's exactly how that hack took place. But after it did, Apple patched that vulnerability, so maybe. Security misconfiguration. Yeah, I always hated this type of a list, but as going through the bug crowd data and high profile data, we realized that we sort of needed to have this kind of catch-all, right? Other OWASP top 10 standards use it. It's basically saying that due to some sort of human error, whether that's how you're deploying it or a developer made just some horrific mistake, the API is not behaving the way that it should. It's not doing exactly what we expect, and it's causing problems. It's opening the attack surface. It's causing more vulnerabilities. So this can either lead to flaws that we talked about before in the rest of these lists, or just be kind of uniquely messed up. There's a plethora of weird examples for that, but they're hard to go over without disclosing who they'd apply to. Okay, so we've gone through why API security is important. We've gone through sort of our process, some examples there, and what we consider to be pretty much the top 10 major risk categories when deploying an API, and things that if you're a pen tester, you're probably going to want to look into. Now comes sort of the real, I don't want to say the point of the talk, but it would be great if someone wanted to sort of help with us, because right now it's me and Leif in our spare time. So today we're publishing the first draft of the API Security Top 10. It's going to basically be a nice concise version of the slides that we have here in an easily readable PDF with short descriptions of what's going on. We'd really like to get feedback on what we've seen here, and if any researchers want to, help us create more of these, that'd be great. Again, if it's, hey, you've missed something, that would be great. Or if it's, hey, we don't agree with one of these findings, that would also be great. But our goals, as I mentioned at the very beginning of this talk, are really a lot broader than just saying, hey, we're going to make another top 10 document. It's really easy to display that via the slides and to have a nice presentation where we go through the top 10. But really, our goal here is to sort of make a documentation portal that can really help out developers and pen testers. I sort of moved from the red team when I was CTO at Redspin to the blue team and helping out developers. And it's a little sad how little information there really is out there that's like, hey, we can actually help you write something in a super secure way instead of just like, hey, we're going to teach everyone how to break it, which is admittedly much more fun. But, we have to help the developers too. So we're trying to basically make this portal to help devs write and deploy secure APIs. So we're looking for security researchers to expand on the risks here, to critique what we've already done. Technical writers, to basically create cheat sheet style, tutorials for developers. If we have any designers in the audience, I don't know if this is really the market for designers, but if we have any designers in the audience, basically to help us accurately display our data, make it look pretty, or people, sort of general evangelists, sort of help spread the research programs and recruit new talent to the project. So you're probably saying like, wow, that sounds great. I'm so excited. Like, you guys are the best. This is the best presentation I've ever seen. How can I sign up? Right. And we'd like to tell you how to do that. So you can find the alpha stage of our project at the OWASP wiki. I'm not going to read out that whole URL, but OWASP API Security Project, you can search for it. If you'd like to help, you can contact me directly via my OWASP email at david.shaw@owasp.org. And I just put these slides online. So for all the links and the research and things like that, they're available at dshaw.net/NolaCon_2016.pdf. So thank you guys for being here. I know it's Friday afternoon in New Orleans, so there's that. Any questions or concerns or anything like that?
How do we give away the booze?
I mean, I don't know. I mean, we could just drink it. That's a good question, Leif. No questions, concerns? All right, cool. We took longer than expected, and yeah, please feel free to find us. We're going to be around all weekend. Happy to hang out with anyone or talk about API security or anything else. So thank you guys.
Yeah, we should get a picture in front of our first slides.
Why?